There's lies and there's statistics, especially Nvidia marketing statistics. So this chart isn't a lie, but it is heavily misleading. Now, this video is about Nvidia's GDC presentation, and there's some cool stuff here, and that's what I wanted to focus on. But Nvidia can't seem to get through a single GPU-related presentation without packing it with such a misleading marketing BS statement that I now need to spend time correcting marketing BS rather than focusing on the cool features they're actually presenting, which I want to focus on and I will focus on. But this is literally the first slide in their presentation, so we're going to just go through their presentation. So here's my thoughts on this slide. This is seeming to counter the narrative that the 50 series has horrible supply, because they're saying in the first 5 weeks after launch, the 50 series has actually shipped twice as many units as the 40 series. And I have no reason to doubt that this is technically true, but it does not mean what you think it means. I think this actually means that it's confirmation that the 50 series has had awful supply, at least by each GPU model. Here's what I mean. The RTX 4090 launched on October 12th of 2022 at $1,600 as an absolute ultra enthusiast Halo tier product that is never meant for mass quantities of sales. Not that it doesn't sell a healthy amount, but that is really not what this is targeting. Now, when did the next GPU in the 40 series launch? Well, it was the 4080, and that came out on November 16th of 2022. And if you're either capable of basic addition and subtraction, or maybe ask a computer to do it for you, that is a 35-day gap, and 5 times 7 is 35, meaning that the first 5 weeks of availability was timed absolutely perfectly for this chart to be replacing the RTX 40 series with just the RTX 4090. This is literally just the RTX 4090, absolutely nothing else, being compared with the entire 50 series in its first 5 weeks. This is a very different launch cadence. Check this out. The RTX 5090 launched on January 30th of 2025, along with the 5080, followed shortly on February 20th with the 5070 Ti, and then with the 5070 coming in on March 5th. Now check this out. How many days are there between January 30th and March 5th? 34 days. In other words, we're fitting perfectly into that 5-week window, which means that this chart was released at the exactly right moment to present the 50 series versus 40 series launch in the brightest light possible for the 50 series and the most misleading light possible for consumers who are wondering why it feels like there's no supply of the 50 series. So in other words, this is not technically inaccurate, but if you want it to tell the true story, this is what the chart should actually say. This is the entire RTX 50 series. Remember, no 60 class GPUs have been officially announced at this point. So this is the 5090, 5080, 5070 Ti, and 5070 stacked up against just the RTX 4090 Ultra Halo Enthusiast class GPU. And the entire 4 models of the 50 series initial launch is only twice the supply of just a single ultra enthusiast tier 4090 GPU. And I don't think this means what Nvidia thinks or is trying to make you think it means in terms of saying that the 50 series supply is great. So when retailers are saying that 50 series is not having good supply and it's below the equivalent supply of the 40 series, they're telling the truth, or we have no reason to doubt them, and this chart is not actually discounting that. Because what they're saying is the 4080 versus the 5080, there's a supply difference there, right? The 4090 versus the 5090, there's a supply difference there. 5070 Ti versus 4070 Ti, 4070 versus 5070. If you charted those separately, I have no doubt that the 50 series is doing much worse on supply compared to the relevant launches for the 40 series, but the 40 series was spaced out differently in time, making this a perfect example of there's lies and there's statistics, and then there's Nvidia marketing graphs. Now, this is also showing up on the same chart. I have less of an issue with this one, but since we're on the topic of we're going through the GDC presentation slide deck, and this is the first slide. It has both of these. Now, this one again, I think, I don't necessarily disagree with the sentiment on this one. I do think that most RTX 50 series GPU users do probably use DLSS, Reflex, and RT in a lot of situations, and I think they're great features. And I don't want to make you guys feel like I'm saying these aren't great features that people should be using. But once again, notice that this is just saying over 90% turn on RTX features for 50 series GPU owners. Now, first of all, 50 series GPU owners are not a representative sample of gamers in general, right? The 50 series GPUs have been hard to get and they've been very expensive. So these are your ultra enthusiast customers who are going out there and either paying scalper pricing or rushing out to fight the bots at launch, or paying massively inflated prices to grab these GPUs. And these are very high-end cards and things like that. That's part of it. But also part of it is that this literally just says turn these features on. So literally, if when you launch a game, its default settings have either DLSS or Reflex or RT enabled by default, you are automatically in this stat, even if you ended up turning them off. Now, I'm not saying you should turn them off or that people do turn them off. I'm just saying that marketing slides like this don't really mean what they're trying to make you think that they mean. And that's frustrating. Anyway, so this is the first slide out of the GDC presentation, and those are my thoughts. Let's keep going and hopefully get something that I have less reason to object to. Okay, so what is the next slide in the presentation? Let's keep rolling. I don't know why I zoomed out. Anyway, so we have the RTX 50 series, new era of AI-powered gaming. So this GDC presentation is talking a lot about the uses of AI in gaming, including DLSS 4, which I've talked about a lot already. I really like it. I don't like using certain features in bar charts and pretending certain things are the same when they're not, but the technology itself, I think, is quite good. Also, neural shading, I also think is really cool, and I'm very excited for where this is going. And I don't think this is going to be just an Nvidia thing. I think this is going to be gaming in general is going to start to see more and more use of neural shaders and neural rendering. Also, Nvidia talks about ACE. This is bringing in their AI, AI models into like speech and language and stuff into AI characters in games. And this is actually coming to some real games soon. I do have some thoughts on that. Anyway, we'll have to see see what comes of all of this. Now, they're claiming, DLSS 4 available in over 100 games and apps. No reason not to believe that, and that does seem to be picking up quickly. I do think some of these are through driver overrides, but I do think it's nice that they have allowed the driver override. And again, you can override older versions of DLSS into DLSS 4 through other tools, even if it hasn't been whitelisted in the app. I think DLSS 4 upscaling, the new transformer model, is awesome. And having multi-frame gen available for extremely high refresh rate displays to smooth out the motion fluidity is also very cool. So I do think that's good stuff. They're announcing additional games coming with DLSS 4 as well. Now, they're showing off the advantages of these. Again, a slide that I'm not a huge fan of because I just don't like the fact that frame generation and upscaling are lumped together in these kinds of presentations as if they're the same thing, because they are completely not the same thing, and they have different pros and cons. So that's my issue with these types of slides. So here we're seeing Avowed with DLSS off, 4K Epic RT settings, RTX 5070 Ti on the left, with 35 FPS and a high PC latency of 114 milliseconds. Then they turn on DLSS 4 and go to performance mode upscaling, multi-frame gen 4x, and notice that the PC latency drops. I guess I need to scale my window here a little bit so you can see the PC latency right there. Now, what I don't like about this is the fact that DLSS upscaling does reduce PC latency. DLSS frame generation increases PC latency. Reflex is its own thing that can be turned on independently of upscaling and frame generation and reduces PC latency. But when you throw it all together like this, it makes it seem like it's all bundled together. I'm not saying it doesn't end up being bundled together and producing a better experience, but also the 35 frames here are not equivalent to the 215 frames here, because some of these are generated frames, some of them aren't. Because of DLSS performance, you're actually getting more real frames. Real in the sense that they're responsive, they're actually increasing the responsiveness of the game, and heck, with DLSS transformer model, you actually lose some of the TAA blur, and you can actually even get a little bit better detail, which is really cool. The problem is that this is also lumping in the generated frames at the same time. So you would really kind of need to divide by 4 to get back to how many actually responsive and equivalent to these frames that you're getting, although the actual image quality is not exactly equivalent, better in some ways, probably worse in others compared to the native. And then you're throwing in the frame generation on top. Again, as a math teacher, this feels a lot like combining unlike terms, which is frustrating, where you're just like, I got 3 X's and 5 Y's, so let's just call it 8. Right? They're not really the same thing when you factor in the FPS count, just the FPS counter. It's a little bit frustrating. Anyway, because you could independently use upscaling but not frame generation, or reflex and not, and just anyway. Again, they're highlighting the differences between DLSS CNN model and the transformer model. And this, I think, is absolutely true. The transformer model for DLSS 4 can look as good or better than the old quality mode in many situations with the older CNN model. And this is the thing. Like, with Nvidia making the marketing claims that you need to push back against, like when they had the CES announcement of the 5070 4090 performance for $549, but that's relying on multi-frame gen, then you get a bunch of coverage having to explain why that's not really equivalent performance. Whereas if they had just announced, look at how awesome our new transformer model of upscaling is, then the press could have just been like, yeah, this is awesome, guys. Look at it. This is great. This is basically meaning you can use a more aggressive DLSS setting than you used to, which does actually increase your performance while keeping similar or sometimes better image quality. And this isn't even just supported on the 50 series. That's just the multi-frame gen bit. The actual upscaling, which is a completely different thing than frame generation, is awesome. And it would be really cool to just be able to focus on that and not start videos like this one or the 5070 stuff, the CES announcement, having to push back against BS marketing claims and just focus on the actually legitimately exciting and good stuff. Anyway, now, their next slide is talking about neural shading support coming to DirectX in April, saying accelerate RTX neural shaders with tensor cores through the Agility SDK preview. Now, I actually think that neural shading, neural rendering in general, is really exciting. I think that this could end up really dramatically increasing what you can perceive you're getting in games without the associated dramatically increased performance and VRAM costs. And I think that's really important. However, I'm really hoping that the way this gets rolled out is not going to be there's a version that works just for Nvidia and their tensor cores, and there's a version that works for everybody else. I'm hoping that's not what we're seeing here, and since I am not a game developer, I am not as up to date on exactly how this works. I think it's really important that we get DirectX features that are supported by all GPU vendors that can unlock their, that can run on their own matrix, multiply and compute, acceleration, however they choose to do that. I think that that's really important. And a good example of why this is important is another controversy surrounding the 50 series GPUs, where we saw that Nvidia used to push GPU accelerated PhysX as one of their big selling points, a vendor exclusive thing, a reason games are better on Nvidia than anybody else. But the 32-bit CUDA support that some of the older 32-bit PhysX implementations run on has been phased out with the 50 series. And that means that your newer Nvidia GPUs can now no longer do the cool Nvidia-specific thing that they used to do, and older Nvidia GPUs actually run those games better than the 50 series does when you turn on those cool features. And the PhysX features were actually really cool. But Nvidia has a track record of these, kind of vendor locking technologies rather than making them an open standard that other GPU vendors could choose to support if they wanted to implement hardware and things like that. So I just want to be clear that my stance on neural rendering is that I think this could be a very cool thing, and I do think that consoles and AMD are pushing in the same direction. We have a lot of evidence about AMD talking about their partnership with PlayStation on Project Amethyst to talk about neural networks for GPUs and for gaming graphics specifically. We've seen FSR4 already paying off as a version, as an example of that. AMD has showed off neural denoising and things like that, which I think still needs some work based on what they've shown off. But Sony's Mark Cerny has talked about, this just being some examples of this. They're pushing again to open up neural rendering to game developers. And I think that that's great. I'm just hoping we don't move into a split where there's a difference in how this is programmed and supported between GPU vendors, because I think that leads to, it's just not the way I think the industry should move, especially with something as exciting as neural rendering, because I do think this is actually really cool. Now, again, I am not a game developer, a graphics programmer, or an AI expert, but as I've tried to understand essentially, why is this cool? Why is it cool to have neural rendering? Here's the best way I've come to understand it, and I'll try to explain it in that way to you. Because again, a big part of my job as a math teacher is trying to make sure, can we comprehend something in simpler terms, as what is this really telling us, right? So as I understand it, you could write a GPU shader in the traditional manner that is as complex as you want. You could have it do something that just takes way too long to compute in a traditional manner. You could write an extremely complicated GPU shader. However, if you write that, it's not useful in real time. But what if you then had an AI model train on that GPU shader program to try to get an approximation of it that can, this has an input-output relationship. You can get an approximation of this, and then the GPU actually running the game can, instead of running the complicated shader, can just inference the AI model that approximates that complicated shader, and it can do this in a fraction of the time, a fraction of the frame time cost of actually computing the complicated shader if it was done in the traditional manner. And this can also bring not just frame time benefits, but reductions in the amount of memory footprint that's necessary to do this, and all sorts of things. So that's how I understand this, is that basically any kind of function with inputs and outputs could be approximated through some kind of AI, which could then be inferenced on the GPU. And so to me, this is extremely exciting, because it seems like the sky is actually the limit on what you could attempt to do with this. Now we'll have to see how all of those models play out in practice. But I do think neural rendering could end up being a big breakthrough to try to push through a little bit of the more traditional stagnation we've seen in the market. GPU generations in raw compute are not seeming to offer the kind of performance uplifts, and especially not the performance per dollar uplifts that we saw in previous generations. And unless something really changes on breakthroughs in advancing nodes, I don't see any reason why that would change in the near future. But if neural rendering could push more advanced graphics, but through a different paradigm on how that's computed, perhaps we could get some big breakthroughs without needing the being held back by the node advancements and things like that, which seems to be what's going on right now. Anyway, again, FSR4, DLSS4, transformer model, these are exciting examples of this, along with the newer versions of ray reconstruction, and then they're also showing off their neural materials and neural textures, things like that. Anyway, cool stuff. Another big announcement from Nvidia here is talking about RTX Remix. Now, this is another thing that I think is pretty cool, where Nvidia has given tools to allow older games to be kind of put into a new box. And this is a new box that might not, it might allow you to do a lot more stuff than the old engine could do. So It's very cool. You can insert, path tracing, DLSS features, all sorts of stuff in a very cool way. I do think RTX Remix is pretty exciting. And so they're kind of just publishing that, hey, this is a community that's continuing to build, and this is another place where I think Nvidia is doing something kind of cool. Of course, they do have the benefit of all these RTX features are going to help their branding and everything like that. So obviously they benefit from this, but that doesn't change the fact that some of the stuff being implemented through this is pretty cool. And RTX Remix is now officially released. Previously, this was a beta. So the idea is you can take the original game, take it into RTX Remix, do character replacements, RTX skin, RTX volumetrics, stage manager, etc. And then you have your RTX mod, which then updates the game. Now they're showing off, how their performance improvements with the various DLSS features and neural radiance caching and all of that. And then they're talking again a bit about how this implementation takes place. Again, if you're interested in this kind of modding stuff, I would say look for a different guide on how to use all of that rather than this video getting into the details on that. But in general, they're showing off the kinds of improvements that you can get from this. Here they're showing off RTX skin. As again, I think this is another example of like a neural rendering technique where you can see some looks like better like maybe subsurface scattering and such underneath that on the RTX skin. Anyway, interesting stuff, RTX volumetrics, and they're showing all of this off in the RTX Half-Life 2 demo, which will be available March 18th. That's coming pretty soon. And I think that is pretty cool. I'll be excited to play this and maybe test out the performance and whatnot on the channel. Let me know how interested you are in that. Now, the NVIDIA ACE stuff, I really need to see how this gets implemented to decide. Like I do think there's a future for AI language models and text-to-speech and all of that being involved in games. But I'm really curious which games end up having this fit, because I think in a lot of games, you might just try to shoehorn this in and it doesn't really improve the experience. Now, I don't know how to pronounce this game. I apologize. Is this Inzoi? Anyway, Inzoi? But this seems to be more of a simulation-based game where perhaps having AI characters are more fitting. Because if you have a simulation-based game, then having more advanced character behaviors and interactions and things like that is maybe a good fit for this style of game. Anyway, I'm curious for people who are actually into this game and this style of game, your feedback on that in the comments section. Because, yeah, I'm interested to see where this type of AI in-game makes sense, the more of the language model and behavior stuff. Now, where I feel like it doesn't make as much sense is in AI companions that talk to you in like competitive games and whatnot. I don't know. I'm not quite as sure it fits here as it does in like a simulation-based game. We'll have to see how that plays out. Anyway, that's pretty much the presentation at GDC. Hopefully you guys found the video useful and or interesting. Let me know your thoughts on all of this in the comment section. I really do think we're moving to a point where AI is going to be being used more and more in gaming. And I think we're going to see certain places where it fits really well and is really exciting. We've already seen that with upscaling. I think that other places, it'll try to get shoehorned in and maybe not end up actually fitting well or being that revolutionary. All right, hope you guys have an excellent day.